Ntinda Vocational Institute is a center for excellence of vocational training, and we offer 5 courses. Ntinda Vocational Training Institute is assessed by DIT, that is Directorate of Industrial Training of the Ministry of Education, and offer competence-based training and assessment to see that Uganda has competent technical people who are proficient and who are result-oriented. So, who is doing that? That is the electrician, the domestic electrician. And how is he going to do it? You don't do it in any way you feel like. There is a way you have to follow, and we do it in accordance with IEE stroke IEEE stroke IEC. IEE, that is Institution of Electrical Engineers, or Institution of Electrical and Electronics Engineers. Now it was compounded to the International Electrotechnical Commission. They set rules, preset the international, and which we follow. So the electrician who wears this lamp, following this, the way it is wired here is the way it is done in Kenya, in Europe, in America, in Australia, and everywhere in Africa. That is, it is international. So an electrician who does this, the way he will do it, he will be competent and internationally acceptable. So now within, yes, we've got time frame. This work here at least has to do it in 1 hour maximum. So now, when you are going to do this work, there are steps to follow. You don't just come and do. There are steps to follow, or which we call processes. Now, which are these processes? We go through the processes. For example, the first one is site survey. Mark the points and make the line diagram, make the circuit diagram, make the material estimations and procure them, install the points and do the cabling, and then you do the termination, test the circuit with a meter, and finally you power the circuit. And then that's when our DIT can come and assess, have you done it well? I think I have to upload DIT for the that work which is doing. It's really a very good job. Thank you, DIT. So now, let's go. Step 1, site survey. When you are given a job, the client takes you to the site, and you see the site. But then you've got to go and survey the site yourself. What is there? What are the risks? Which risks are involved? Which space do I have? How can I mitigate those risks? How can I overcome them? What do I need? How long is the distance from my workplace? What do I need to go with? How many people do I need to go with? So you do the site survey and resurvey as well. Then you mark the points. Now, this is my site. This is where we are going to work from. And this is where we are going to put our lamp. So we mark the points. We are going to mark the points, as we shall come to that, to mark the points. Then after marking the points, you make what we call a line diagram. Now that is the geography of the work from here to there. Now this is our line diagram. We have a lamp. We have a terminal place, a terminal point where we carry out our terminations, where we call the joints and the connections. Then we have the switch place. So this is called a line diagram. Then step number 3, we go to what we call making the circuit diagram. You know, a circuit in electrical engineering, it is a complete flow of electric energy and should be doing some work. If it just goes and it short circuits and goes back, then that will be a short circuit. But it has got to get a load, and in this case, our load is the lamp. So we have the supply point. Where does the power come from? The power has to come from a source somewhere. From the source, whether the mains or from the battery or from solar, there has to be a source. Then when the power comes, it has got to come to a place where it will be terminated and be channeled to the control point, that is the switch, and from the switch to the load point, that is the lamp. So you get to know the actual thing manually, point by point, place by place, and it is well drawn. Now, this is a critical point. Electricians, listen to me properly. All eyes on me, all over viewers. Never carry out any electrical work without a circuit diagram. Never carry out any electrical work without a circuit diagram. This is what leads you, and it's the one on which you follow. You'll never make a mistake. And even if you make a mistake, it will be minor, not deadly. Now, from there, we go to what we call make the materials estimation. Now, the materials estimation and procure them, and the tools as well. So now we are going to see the tools. Which tools do we need? Which materials do we need? Now, we need screwdrivers, we need side cutter, combination plier, hammer, phase tester, multimeter, and electrician's knife. Now, Maureen, help me. Show us. First of all, we have the screwdrivers. Yes, I see the screwdrivers, which we are going to use. We've got this screwdriver. The screwdriver, we've got the minus and the star. All right? Now, we need the side cutter. The side cutter, this one here. The side cutter. We need combination pliers. Combination pliers. We need a phase tester. This one here. It tests for whether the conductor is live or not. Then we need a hammer and the electrician's knife. We shall see the multimeter later. Now, from there we go to the materials. Which materials do we need? We need the materials as well. Now we need a 1.5 millimeter squared twin cable. Now, we don't say 1.5 millimeter only, it is incomplete. It is a 1.5 millimeter squared twin cable. Because for lighting, we might not need the earth. We need, I think now we go as you are showing us. This is our cable. We say a cable because it has got more than one conductor. If it is one conductor, it's just a simple conductor or wire. But if it has two conductors or more, that one is a cable. And the size which we need is 1.5 millimeter squared twin cable. Now, we need a one-gang, one-way, single-pole switch. Electrician, listen to me. If a switch has one button, that is what we call a gang. If it has two buttons, those are two gang. Now, these are two gangs. The button, we can set two buttons. But now in electrical, we don't say two buttons, we say gang. So this one is a gang. This one is two gang, and the one we are going to use is one gang. One-way, single-pole switch. We need a lamp holder. Now, this lamp holder is called a button straight lamp holder because it is wall-mounted. We also have a pendant. The one which swings, the pendant lamp holder, and it's put on the, this is the ceiling rose on the ceiling, and then we put the lamp holder here. It is pendant swinging, but this one is button straight. There's one which is button bend, which some people call it angle, but this one is button straight lamp holder. We need a bulb. This is the bulb. Now, we need a joint box. A joint box, yes. Now, this is where we carry our terminations. Okay, they put the joint box here, and at the same time, it's the one which is here. This is where we carry out the terminations, or the connections, or the joints. Now, we need this mold box. Some people call it the MK box. But now here we localized it that the MK box is usually for the wall mounted, where it is flash wiring, it is inside the wall and you cast it in cement. But this mold box is for surface wiring. So we put it on the wall, you fix it on the wall, and you put the switch. So that's why we call it a mold box. Then the rest are small accessories. We need tower clips, which will help us to clip the cable on the wall. Okay, this one called a tower clip. And we also need screws. We need screws. As I said, we need the tower clips. This is the tower clip. Okay, the clip, it holds the cable, and then you hammer. You need this clip Then you clip in the cable. Then after clipping the cable, then you hammer this nail into the wall or on the wiring surface. Then this screw is to fix these accessories, the joint box and the mod box onto the wall so that things are fixed and you carry out the clipping, what we call the cable lay and the termination, and the work gets done. We said that our task is to wire a lamp controlled by a one-gang, one-way single pole switch. We've seen the one-gang, one-way single pole switch, and it is with the electrician to carry out this work. And how well, in accordance with International Institution of Electrical Engineers, or Institute of Electrical and Electronics Engineers, or International Electrotechnical Commission. And we have seen the steps, we have seen the drawings, we've seen now the circuit diagram, we have seen the materials which are required, and the tools which are required. So now next is to go manually and practically on the work so that we do it practically and programmatic and we see the results. We are now going to go practical to do the pragmatic part of our installation. We are going to wire this one lamp controlled by one gang, one-way single pole switch, and this is our terminal point where we carry out the connections, which we call the joint box. Many electricians call it a junction box. No, junction is for conduit work, but for wiring work, it's called a joint box. And this is our power source. So now, before we do the work, you have to do what we call the measurements and the sketch. So, if you can see here, we carried out measurements to measure the cable which you are going to use. You measure the cable you are going to use. So it is something which is like this. So this is our joint box. This is the switch. This is the source. And this is the lamp. So we carry out measurements so that we don't waste material. So now we are going to step number 5. Install the points and do the cabling. We have installed the points. This is the switching point, connection point, and the lighting point. Now we do the cabling. Now the cable has to be straight. The cable has to be straight, and you clip at intervals. You do the clipping at intervals, not too near and not too far. Yes, that is clipping. Now we come to the switch point. Now, before we clip here, we have got to terminate. Now, this is a critical point. Some people make the length longer or shorter. Now you bring this length at the end of the joint box, so that part of it enters in the joint box and the other part is for termination. So here I do the cutting. We brought it towards the end here and we cut. Now after cutting, you strip. When you are stripping, you press, okay, at around 30 millimeters, which is 3 centimeters, which is slightly more than an inch. When it has really recut, you bend the knife at 30 degrees and then you strip. If you carry it at a sharper angle, you will injure the conductor. And once you injure the conductor, you will reduce its current carrying capacity. So what you do is to be very careful and carry it at 30 degrees and then you strip. After removing the sheath, now you remove this final insulation from the conductor. So it is removed, then you twist it so that the strands are not sporadic. They don't go in various directions. They should be one. This electrical knife is very sharp. So now we made our conductors. Now after, you have to take it back. Don't leave, it's very sharp and dangerous. So you've got to, that is material and tool handling. The next step is to do the termination. What do we mean by termination? That is connecting, making the connections and the jointing. And this is critical. Now these are electrical joints. The IEE wiring regulations stipulates that an electric joint should be electrically continuous and mechanically sound. It shouldn't pull out under normal strains. So we are going to make our joints firm. Now, according to our circuit diagram, we see the neutral conductor. When the neutral conductor comes, it goes straight to the lamp. The neutral conductor, it goes straight to the lamp. This is our neutral incoming. So it is going direct to the lamp. So we connect it directly to the lamp. We said electrically continuous and mechanically sound. It should not pull out under normal strains. Fine. Right, now we see our live conductor coming. The live conductor here, we see the live conductor, it has come from the supply, it goes to the switch. The live conductor has come, it goes to the switch. Now we connect our live conductor. This is the incoming live conductor. We connect it to go to the switch. Now the switch has got the supply. Now from the switch, our conductor, which comes to the switch, now from the switch, now it is going to the lamp. Now this is our termination point where we connect the conductor from the switch to the lamp. Now we see it coming from the switch. This is our conductor which comes from the switch. It goes to the lamp through the terminal point. We are almost done with the termination. Coming stubborn, we are saying it has to be electrically continuous and mechanically sound. It should not pull out under normal strains. No pulling out under normal strains. Short circuits and loose connections are the major cause of electricity burns in houses. So the joints have got to be firm. So these are our joints. Now finally we come to the switch. Now our switch has two terminals, the incoming and the outgoing. We terminate the switch. We call it connecting the switch. Now we don't fix the switch in here before we have tested. Now we bring our multimeter. Now you are going to hold the multimeter. We are going to put in continuity. Okay? Now it can either put in it can make a sound. Okay? That bringing sound, or it can even read. Now, is there continuity? When we switch on, is there continuity? For example, is there a short circuit? So, for example, have to take measurements. Is there any short circuit? It's not making any sound. Otherwise, now, when we switch on here, this is our lamp coming. This is the one going to the switch. When we switch on from the switch, is it making any sound when we switch on? Is it making any sound? No. Then if it doesn't make any sound, it means that the switch might be faulty. It's not continuous. But then let's see, we shall see with the lamp. Okay? So, after testing with the multimeter, do we have power Anyway, let us see. Can you please switch on, put on the socket and switch on? Yes, we have power. Now switch off and pull out and we connect the power. Have you pulled out? Now we connect the neutral to the neutral and the live to the live. Switch on. Now can you come and switch on and off and on, hold it here. Switch on and off, on and off. If there's a short circuit, it would have brought problems. Now let us put in our bulb. Can you switch on and off? So that is our lamp. Switch on, switch off, switch on. Now, finally, switch off. Finally, we close the switch with a screw. And the joint box cover we cover. But now, before we do the covering, DIT, for assessment purposes, it will come to see, are these joints firm? Are they firm? Is there continuity? Did you make the terminations firm? Is the work okay? Is it well done? Then, after you have seen that you will not be caught off guard, you do the covering. Finally, we say that we have come up with, we have wired a lamp, this lamp, controlled by a one-gang, one-way, single-pole switch by the domestic electrician. I want to say thank you so much to Directorate of Industrial Training, UBC crew for this time to learn, Ntinda Vocational Training Institute, the Center for Excellence.